Hi, I'm Dr. Chris Creighton, and in this video we'll be learning about linear inequalities. So your goal after this video is to be able to graph the solutions to systems of linear inequalities, but we're going to start off with just graphing a single linear inequality. We're going to start off with an example of graphing a solution region to a linear inequality. What makes it a linear inequality is instead of an equal sign, we have this less than sign. So linear inequalities have less than or equal to, greater than or equal to signs instead of an equal sign. So what it's saying is that the values that x and y can obtain have to be less than or equal to 3 when plugged into the equation for the line. So like for example, if I choose the value, the point 1, 1, so x is 1, y is 1, when I plug that into the equation, I get 3 times 1 minus 1, and I'm using parentheses to denote that I'm plugging them in for x and y to help with bookkeeping, which is equal to 3 minus 1, which is 2, is less than 3. So then that tells me is that 1, 1 is a point in the solution region. So if you plug in a point, so if we try another point, say 0 comma minus 3, plugging that in, we'll get 3 times 0 minus negative 3. So the parentheses here help us to keep track of what we plugged in. It also helps with this double negative here. So this is in fact equal to 0 minus 3, which is 3. Now if we wanted to compare it with the value 3, that is not less than or equal to. So this is not a point in the solution region, but it is a point on the line. So in this case here, we would want to include the region that has the point 1, 1 in it, but not include the line itself, which includes the point 0, negative 3. 0, negative 3 is on the line if that was an equal sign instead. So I added a quick graph here. So this line can be drawn quickly using the x and y intercepts. This is if there was an equal sign, so like if we're going to graph the line 3x minus y is equal to 3, you can quickly read off the intercepts. So for instance, if I plug in 0 for x to get the y-intercept, we get the y-intercept is down here at negative 3. And if I plug in 0 for y, we will get the x-intercept is here at 1. So now I'm going to play connect the dots to get us the graph of that line. So I drew this solid, but I want to point out that less than does not include the line in its solution. So what that means here is that we should make this a dashed line. That is the convention here. So when we graph this line, we make it dashed. So that means make this a dashed line. So since this is a dashed line, we now know that it's not included in the solution region. Next, we need to figure out which side is the solution. So fortunately, we've already done some work with that. So I already plugged in a point 1, 1. So 1, 1 is right there. It's just barely off the line, but it's off the line. This is a point in the solution region. Now the solution region is either going to be this area or this area. It's going to be on either essentially the left side or the right side. So in this case here, we have a point in the solution region on the left side, the solution region is everything on the left of the line. So this is the solution region. So to go through what we just did, what are the steps that we followed to graph the linear inequalities? So the first step I would say is to graph the line as if it was an equality. That's the first thing we did. We took the graph and we're like, okay, we graphed this line. Step 2, determine if it's dashed or solid. And if it's dashed, make sure to erase or not draw it solid. And it's dashed if it's less than or greater than, and solid if it's less than or equal to or greater than or equal to. And then 3, you then choose a point not on the line and plug into the inequality. So that's what we did for the point 1, 1 in the prior example. We chose that point. It is not on the line. I mean, I just picked it at random. And notice that it satisfied the inequality. So if it satisfies, the inequality, shade that region. So what I mean by that is if you choose a point 1, 1, and that satisfies the inequality. So that gave us a value less than 3. That's what we wanted. That means the region, including 1, 1, was shaded. If it does not, though, shade the other region. And so what I mean by that, if I picked another point, say like something a little bit farther out, like 5, 1 in that prior example, that was on the other side of the line. It would not have satisfied the inequality. So like for instance, if I choose 5, 1 as our point, 3 times 5 minus 1 is equal to 15 minus 1, which is 14, which is certainly much larger than 3, and so that violated our inequality. We wanted this to be less than. All right. So since 5, 1, if we had chosen 5, 1 as our point, would have violated the inequality, and so it does not satisfy the inequality, so then we would have to shade the region on the other side of the line.